On the night of May 1, 1915, in a comfortable house in a leafy suburb of Berlin, a woman named Clara took her husband's army pistol out into the garden. She was 44 years old. She had been the first woman in Germany to earn a doctorate in chemistry, and she understood exactly what her husband had built. A week earlier, he had stood on a battlefield in Belgium and ordered the release of a green cloud that choked thousands of men to death in their own trenches. That night, Clara fired a shot into her own chest. Her 13-year-old son heard it, ran outside, and found her dying on the grass. The next morning, her husband did not stay for the funeral. He boarded a train for the Eastern Front, where another gas attack was waiting for his command. The man whose wife died that night is the reason roughly half the people alive on Earth today have enough to eat. He pulled bread out of thin air. He also fathered modern chemical warfare with his own hands. His name was Fritz Haber, and his life is the strangest and most disturbing argument ever made about whether a discovery can be separated from the man who makes it. This is the story of how one chemist saved billions of lives and ended hundreds of thousands of others, won the most prestigious prize in science, while half the world called him a war criminal, and was finally driven out of his own country by the very hatred his greatest weapon would one day serve. To understand Haber, you have to start with a problem that almost nobody remembers now, because he solved it so completely. At the turn of the 20th century, the world was running out of food, and the smartest people alive knew it. The reason was nitrogen. Every living thing needs nitrogen to build protein, and the air is almost 4/5 nitrogen gas. But that nitrogen is locked up tight. Plants cannot pull it from the sky. For all of human history, farmers had depended on a thin supply of usable nitrogen from manure, from rotting plants, and from a few natural deposits scattered around the globe. The richest of those deposits was bird droppings, guano, piled up over centuries on islands off the coast of Peru and Chile, and saltpeter mined from the deserts of South America. Britain, Germany, and the United States fought over access to it. Wars were fought over bird waste, because bird waste fed armies and grew the wheat that kept cities from starving. The trade in that fertilizer was a brutal business. On the Guano Islands off Peru, gangs of laborers hacked into mountains of compacted bird droppings in choking clouds of ammonia and dust, loading the stuff onto ships bound for Europe and North America under conditions so cruel they became a scandal in their own time. The saltpeter beds of the Atacama Desert were so valuable that from 1879 to 1884, Chile, Peru, and Bolivia fought a full-scale war over them. The conflict history remembers as the Saltpeter War, which redrew the map of South America and left Bolivia landlocked to this day. The richest nations on Earth had built part of their food supply on a resource that was being mined out faster than nature could replace it, fought over with armies, and shipped halfway around the world. Everyone with eyes could see the supply would not last. In 1898, a British chemist named William Crookes stood before a scientific society in Britain and said out loud what everyone feared. The world's supply of natural nitrogen was finite. The population was climbing. Within a generation, he warned, the wheat-eating nations would face famine on a scale never seen unless someone found a way to make nitrogen fertilizer from a new source. He pointed to the obvious target. The air above our heads held an almost infinite ocean of nitrogen. Whoever could learn to break it apart and bottle it would feed the world. Many chemists tried. They failed. The nitrogen molecule is held together by one of the strongest bonds in nature, and it does not want to come apart. Coaxing it to combine with hydrogen to make ammonia, the building block of fertilizer, seemed to require pressures and temperatures that no equipment on Earth could survive. Fritz Haber was not the obvious man to crack it. He was born in 1868 in Breslau, a Prussian city that is now Wrocław in Poland, into a prosperous Jewish merchant family. His mother died giving birth to him, a shadow that historians believe followed him all his life. His father was a hard, practical dye and chemical trader who never quite approved of his restless, ambitious son. Young Fritz wanted desperately to belong, to be fully German, to be accepted by a country that kept Jewish men out of its best universities and army commissions. In 1892, at the age of 24, he was baptized as a Protestant. He told himself it was a step toward the nation he loved. It would not save him, and in the end, it would not even convince the people he was trying to impress. But that hunger to be useful, to be needed by Germany, drove everything he did. He bounced through a few jobs and a failed early career before he found his footing in the new field of physical chemistry, the study of how energy and chemical reactions interact. He was brilliant, restless, and relentless. By the early 1900s, he held a professorship in Karlsruhe, and he turned his attention to the nitrogen problem that had defeated everyone else. Working with a young British assistant named Robert Le Rossignol, Haber built a tabletop apparatus of steel and high-pressure valves. He squeezed nitrogen and hydrogen together at enormous pressure, heated them past 500 degrees, and pushed them over a catalyst, a metal that helps the reaction along without being used up. In the summer of 1909, drop by drop, his machine did the impossible. It dripped out liquid ammonia made from nothing but air, hydrogen, and electricity. He had taken nitrogen out of the sky and turned it into the raw material of fertilizer and bread. A laboratory trickle is not a harvest, though. To feed the world, you have to make ammonia by the trainload, and the pressures Haber used would have burst any industrial vessel of the time like a balloon. This is where the second name in the story enters. The chemical giant BASF bought Haber's process and handed the scaling problem to an engineer named Karl Bosch. Bosch was a genius of a different kind, a man who could build what Haber could only imagine. He spent years failing. The high-pressure steel reactors kept cracking because the hydrogen ate into the metal and made it brittle. Bosch invented a double-walled reactor to solve it. He tested thousands of catalysts to find a cheap one that worked. He built compressors the size of locomotives and a factory unlike anything the world had seen. On September 9, 1913, the first full-scale ammonia plant at Oppau in southwestern Germany went into production. Together, their achievement became known as the Haber-Bosch process, and it is, by a wide margin, one of the most consequential inventions in human history. Think about what that means in plain terms. Before Haber-Bosch, the amount of food humanity could grow was capped by the nitrogen nature happened to provide. After it, that cap was gone. Synthetic fertilizer poured onto fields, and harvests exploded. Today, scientists estimate that the nitrogen pulled from the air by the Haber-Bosch process feeds somewhere close to half the people on the planet. Look at it another way. Of the roughly 8 billion people alive right now, several billion of them simply would not exist without the fertilizer that traces back to that dripping machine in 1909. The nitrogen atoms in your own body, in the protein of the meal you ate today, very likely passed through a factory built on Haber's idea. He is, in the most literal sense, the reason a huge share of the human race was ever born. If the story ended there, Fritz Haber would be remembered as one of the great benefactors of mankind, a quiet hero of the 20th century. But Haber did not want to be quiet. He wanted to be useful to Germany, and in 1914, Germany went to war. When the First World War broke out, Haber threw himself at the German cause with an intensity that unsettled even his friends. He was 45, too old to fight, but he put on a uniform anyway and turned his prestigious Berlin Institute into a weapons laboratory. At first, his contribution was the same one that fed the world. The British Navy had blockaded Germany and cut off its imported saltpeter from South America, and saltpeter was needed to make explosives as well as fertilizer. Haber-Bosch ammonia could be turned into the nitrates that filled German shells. The same chemistry that made bread also made gunpowder, and without it, Germany might have run out of ammunition within a year, and the war might have ended much sooner. So Haber's discovery extended the slaughter on both sides of the ledger, feeding the home front and arming the guns at the same time. But Haber wanted to do more. By the winter of 1914, the war had frozen into the trenches. 2 lines of men dug into the mud of France and Belgium, neither able to break through. Hundreds of thousands were dying for a few yards of ground. Haber proposed a solution that other German scientists found monstrous and that he found simply logical. If you could not blast the enemy out of his trench, you could poison the air he breathed. He championed the use of chlorine gas, a heavy, choking, greenish vapor that would sink into the trenches and drive the soldiers out or kill them where they stood. There were even rules against it. The Hague Conventions, signed before the war, banned the use of poison in projectiles. Haber found a cold loophole. He would not fire the gas in a shell. He would simply open thousands of cylinders and let the wind carry the cloud across no man's land. Technically, he argued, that broke no treaty. The reasoning is chilling precisely because it is so careful. He personally went to the front to make it happen. Through the early months of 1915, he was at Ypres, in Belgium, in his uniform, smoking cigars, studying weather charts, waiting for the wind to blow in the right direction. He had thousands of steel cylinders of chlorine buried along the German line. He needed a steady breeze toward the enemy, and for weeks the wind refused to cooperate. Then, on the afternoon of April 22, 1915, the conditions were right. At around 5 in the evening, German troops opened the valves on nearly 6,000 cylinders and released about 168 tons of chlorine gas along a 4-mile stretch of front near the village of Langemarck. A yellow-green wall, taller than a man, drifted silently across the open ground toward French and colonial Algerian troops who had no idea what was coming. What followed was a kind of horror the world had never witnessed. Chlorine reacts with the moisture in the eyes, the nose, and deep in the lungs, turning into acid. Men felt their chests catch fire. They coughed up a yellow froth, clawed at their own throats, and drowned standing up as their lungs filled with fluid. Those who could still move ran, and the line broke. A gap several miles wide opened in the Allied front, undefended, the kind of breakthrough generals had dreamed of for months. And then nothing happened. The German command had not really believed the gas would work, and had no reserves ready to pour through the hole. The soldiers themselves were afraid to advance into the poison they had just released. By the time the army reacted, the Allies had rushed in troops and sealed the gap. Thousands of men had died in agony, and the front had barely moved. Haber had opened the door to a century of chemical warfare, and his own side had been too horrified to walk through it. 2 days later, the Germans gassed Canadian positions, who held the line by soaking cloths and pressing them over their faces, and the Second Battle of Ypres ground on into a bloodbath. Within a year, both sides were using gas. Chlorine gave way to phosgene, which killed more quietly and more surely, and then to mustard gas, which blistered the skin and burned the lungs and blinded men for weeks. By the end of the war, poison gas had caused well over 1 million casualties. Haber threw himself into all of it. To run his gas program, he built a unit of scientists, and the names on its roster are a quiet astonishment. Haber recruited some of the finest young minds in German science into the gas troops, and several of them would go on to win Nobel Prizes of their own. James Franck and Gustav Hertz, who later shared a Nobel for their work on the atom, served in Haber's gas units. So did Otto Hahn, the chemist who would one day discover nuclear fission and earn his own Nobel, and who was sent up to the front to help direct the clouds. Hahn later admitted he had felt ashamed of the work even as he did it, troubled by the idea of killing men with gas, and that Haber had brushed his doubts aside with the argument that ending the war faster would spare lives in the long run. A generation of brilliant scientists passed through that unit and carried what they saw there for the rest of their lives. Haber sat at the center of it all, the organizer, the believer, the man who had convinced himself that mastering the cruelest weapon of the age was a form of service. He organized the gas troops, developed new agents, designed the masks to protect German soldiers from the very weapons he was unleashing on the enemy. He was, by any reasonable measure, the father of modern chemical warfare, and he was proud of it. He believed gas was no crueler than a bullet or a shell, and that a quicker German victory would save lives in the end. He once said that in peacetime, a scientist belongs to the world, but in wartime, he belongs to his country. It was his defense and his conscience all in one sentence. His wife did not agree. Clara Immerwahr had been a remarkable woman in her own right, the first woman to earn a doctorate in chemistry from the University of Breslau in 1900. She was Haber's intellectual equal, and she had given up her own scientific career to marry him in 1901, sinking slowly into the role of a professor's wife in a society that had no place for a woman scientist. She watched her brilliant husband turn his gifts toward killing, and it broke her. By her own account, she called the work a perversion of science, a corruption of the very thing she had devoted her life to. The two of them fought bitterly about it. After Haber returned from his triumph at Ypres, after the celebrations and his promotion, the marriage reached its breaking point, and on the night of May 1, 1915, Clara took his service revolver into the garden and shot herself. She died in the arms of their young son Hermann. Sit with what Haber did next, because it tells you everything about the man. His wife was lying dead, his teenage son was shattered, and the very next morning Fritz Haber left for the Eastern Front to supervise a gas attack against the Russians. He did not stay. Some who knew him said he was a man simply incapable of stopping, that work was the only place he could hide from grief. Others saw something colder. Either way, the image is unforgettable. The man who fed the world, stepping over the body of the wife who begged him to stop, on his way to release more poison gas. When the war ended in defeat for Germany, Haber's world cracked in two. He had been a national hero, and now Germany was crushed, humiliated, and buried under a mountain of reparations it had no clear way to pay. Haber, ever the patriot, decided he would rescue the country with chemistry one more time. He had read that the world's oceans held billions of tons of dissolved gold, and he became convinced he could invent a way to harvest it, sell it, and settle Germany's debts. For years, in secret, he and his team tested seawater samples from around the globe, even sailing on ocean voyages to measure the gold content of the water. The dream collapsed under a hard fact. The amount of gold actually dissolved in the sea was a tiny fraction of the old estimates, far too little to ever extract at a profit. He had poured years of effort into rescuing a nation that, within a decade, would brand him an outcast. It is one of the quiet ironies of his life that the great chemist's most patriotic post-war project was, in the end, a fantasy. He had a darker fear in those years too. He lived under the shadow of the gas, dreading that the victorious Allies would name him a war criminal and demand he stand trial for the clouds at Ypres. His name did appear on early lists of Germans the Allies wanted to prosecute. For a time he grew a beard and slipped across the border into Switzerland, half in hiding, unsure whether he would be arrested. But the prosecutions never came together, the political will faded, and Haber was never tried. Instead, in 1919, something almost unbelievable happened. The Royal Swedish Academy of Sciences announced that Fritz Haber had been awarded the Nobel Prize in Chemistry, held over from 1918, for the synthesis of ammonia from its elements. The decision detonated a storm. To the Nobel Committee, the logic was clear. Haber's ammonia process was a gift to all humanity, a solution to world hunger, exactly the kind of benefit to mankind that Alfred Nobel's will demanded the prize reward. But to much of the world, especially in the countries whose soldiers had drowned in his gas, honoring Haber was an obscenity. Several Allied scientists protested. Some who had won prizes that same year refused to be associated with him. The newspapers caught the contradiction in a single brutal line. noting that the same man had suffocated thousands of soldiers and saved millions from starvation, and now held the world's highest scientific honor for the second half of that sentence, while the first half was still fresh in the ground. There he stood at the ceremony, accepting a medal for feeding the world, less than 5 years after a green cloud at Ypres made his name a curse. No one before or since has embodied the double edge of science quite like that. Through the 1920s, Haber rebuilt himself once more. His institute in Berlin became one of the finest research centers in the world, a magnet for brilliant young scientists, many of them Jewish, drawn by his energy and his support. He had remarried, though that marriage also failed. He was lionized in German science, showered with honors, the grand old man of chemistry. And in those same years, in a quiet corner of the work his institute had touched, a different seed was growing, one that would close the circle of his life in the cruelest way imaginable. During and after the war, Haber's circle had worked on pesticides, ways to use poison gas not on soldiers, but on the insects and vermin that destroyed crops and spread disease. It was, in their minds, the gentle cousin of chemical warfare. Science turned back toward protecting human life. Out of that work came a line of cyanide-based fumigants. The early version was called Zyklon, refined and made safer to handle, with a warning odor added so people would not be poisoned by accident. It became a commercial pesticide called Zyklon B, sold for delousing buildings, ships, and clothing. For years, it did exactly what it was designed to do. It killed lice and rats. Haber himself did not invent Zyklon B in its final form, and he was dead before the worst of it. But the institutional roots, the expertise, the very idea of mastering cyanide gas for pest control ran straight back through the world he had built. Remember that detail. It matters more than almost anything else in his story. Because in 1933, everything Fritz Haber had spent his life trying to be was taken from him by his own countrymen. Adolf Hitler came to power, and within months, the new Nazi government passed laws to purge Jews from the civil service and the universities. Haber had been baptized a Christian for 40 years. He had served Germany in the war as faithfully as any general. He had won it a Nobel Prize and fed its people. None of it counted. To the Nazis, he was a Jew, and that was all. He was ordered to dismiss the Jewish scientists at his own institute. He refused and resigned instead, writing that for more than 40 years he had chosen his staff for their brains and character and not their grandmothers, and that he would not change his ways for the rest of his life. It was the proudest, most defiant act of his life, and it came at the very end of it. He left Germany a broken man, the country he had loved with everything he had, the country he had poisoned his conscience to serve, had spat him out for an accident of birth. He drifted to England, to Cambridge, where the scientists who remembered the gas at Ypres received him coldly. The great physicist Ernest Rutherford reportedly refused to shake his hand. Then came an unexpected kindness from an unexpected direction. Chaim Weizmann, the chemist and Zionist leader who would one day become the first president of Israel, offered Haber a position at a new research institute being built in Palestine, in Rehovot. The man who had spent his life running from his Jewishness was, at the end, welcomed home by it. Haber, exhausted and ill, with a failing heart, set out for the Middle East. He never arrived. On January 29, 1934, resting in a hotel in Basel, Switzerland, on his way south, Fritz Haber died of heart failure. He was 65 years old, a stateless exile, far from the nation he had adored. He did not live to see the final, unbearable turn. After his death, the Nazi regime built its machinery of extermination, and at Auschwitz and other camps, it needed an efficient way to murder human beings by the thousands. It reached for a cyanide pesticide. It reached for Zyklon B, the very chemical lineage that traced back through the institute and the science Fritz Haber had created. The warning odor was stripped out so the victims would not be alarmed, and in the gas chambers, More than 1 million people were murdered with it, most of them Jews. Among the dead were members of Fritz Haber's own extended family, relatives who shared his blood and his name, killed by a poison descended from his own laboratory, ordered by the country he had served, because they belonged to the people he had tried so hard to leave behind. The chemist who gassed the enemy at Ypres had, without ever knowing it, helped forge the weapon that would be turned against his own. So how do we weigh a life like this? It is tempting to split him in two, the good Haber who fed the world and the evil Haber who gassed it, as though they were different men. But they were not. They were the same restless, brilliant, desperate person, driven by the same need to be useful, the same faith that science in service of his nation could do no wrong, the same mastery of nitrogen that filled the world's granaries, filled its shells. The same command of poison gas that he aimed at French soldiers seeded the technology that would murder his own people. He gave the human race the food to grow to 8 billion souls, and he handed it the first weapons of mass chemical death. And he did both for the same reasons, in the same lifetime, often in the same building. His grandson, the historian Fritz Stern, once described Haber's life as the tragedy of the German Jew, the tragedy of unrequited love. Haber loved a country that never loved him back, and he was willing to do almost anything to earn that love, including things that should have been unthinkable. His first wife saw the cost clearly and could not live with it. His son Hermann, who as a boy had found his mother dying in the garden, carried the weight of his father's name to America, and in 1946, after the full scope of the Holocaust became known, he too died by suicide. The shadow Haber cast did not end with him. It reached forward into his own family and into the gas chambers, and forward still, into the fields that feed us now. That is the part most people never learn. The next time you sit down to a meal, the bread, the meat, the vegetables, the protein that builds your body, there is a very real chance that the nitrogen in it came out of the air by way of the process Fritz Haber invented. You are, in a quiet biological sense, partly a product of his genius, as are billions of others who will never hear his name. He is woven into the food on your table and into one of the darkest chapters of the last century, and he cannot be edited down to one or the other. The same hands did both. That is the warning his life still carries, more than 90 years after he died alone in a Swiss hotel. A discovery has no conscience. The mind that makes it does, and what that mind chooses to serve can feed the world or poison it, sometimes in the very same breath. Fritz Haber proved that a single man can be a savior and a destroyer at once, and that the line between the two is far thinner than we would like to believe. If you want more forgotten stories like this one, the people history would rather we never look at too closely, take a moment to subscribe, and we will keep digging them up together.